Welcome guys to the second summary video, and this time we will talk about acceleration. The main three things you should know about acceleration. First of all, as we defined earlier, acceleration is a measure of the change in velocity during a period of time, which means that acceleration exists only if there is a change in velocity. Acceleration is a change in velocity over time. Okay, so whenever we have a change in velocity, we will have acceleration. No change in velocity, no acceleration. Okay, this is the first thing. The second thing we need to know is how do we measure acceleration? What is the unit we use to measure acceleration? Actually, it is meters per second square. Okay, meters per second square. This is the SI unit of the acceleration. What's the meaning of SI unit? International unit system uses meters per second square to be the units that we measure acceleration by it. Okay. Now, how can we calculate this unit? We can represent acceleration mathematically by the change in velocity over time. Okay, because we said acceleration is a measure of change in velocity during a period of time, we can mathematically represent that as acceleration equals to change in velocity over time. And we know that velocity is measured by meters per second and time is measured by seconds. So if we divided these two fractions on each other, it will give us meters per second square, okay, which is the unit we use to measure acceleration. So this is the second point. The first one is acceleration is the change in velocity. Second thing, it is measured by meters per second square. The third crucial thing about acceleration, before going to the third point, acceleration, as we said, exists if there was a change in velocity. No change in velocity, no acceleration. Okay, when we can have a change in velocity only if the speed has been changed or the direction of motion has been changed. Okay, if we change the speed of the object or the direction, we will change the velocity, and hence we will have an acceleration. Okay. The third thing about acceleration, and then an important point about acceleration, is that acceleration is a vector. As we said, vectors are these quantities that must be represented by a magnitude and a direction. Acceleration is an example of these vectors, okay, is one kind of vector. And we took velocity as a vector, and now we know that acceleration is also a vector, which means this acceleration must be assigned by a magnitude and a direction. And we know that we can represent vectors in terms of arrows, where the arrows pointing to the direction of the velocity or the vector quantity. And here we have acceleration. So the direction of acceleration can be represented here from this arrow. It points to the east, so its direction is to the east. Okay? So we now know that because acceleration is vector, it can be represented by arrows. And the longer arrow represents higher acceleration. The same thing for velocity. Longer arrow represents higher velocity, and here for acceleration, longer arrow represents greater acceleration. So the longer one here we have 36 meters per second square, and the shorter one 22 meters per second square. As is expected, it is lower than the previous one. Okay, these are the main three things about acceleration. And now let's talk about forces. Okay, we have said, okay, before we apply, in this example, when we have a stationary object that starts to move from rest from here, 0 kilometers per hour, and then started to move for 5 seconds, reaching velocity or speed and velocity, because it is assigned to the direction, a velocity of 20 kilometers per hour. Okay, So the speed of this object has been changed, which means that the velocity has changed. Then we will have acceleration in this process. But let's ask ourselves this question. What causes the object to move at the first time? Why the object moved from 0 kilometers per hour to 20 kilometers per hour? As we have learned, there must be some kind of forces that acts on this object to move it. Okay, and then we took the other example where an object moves with constant speed, changed its direction. Okay, and we say because the direction has been changed, there must be a change in velocity. So we have an acceleration here. Okay, but the question is, what causes the object at first to turn, to change its direction? Actually, it must be some kind of forces that acted on this object and changed its direction. Okay, so we can claim that forces actually cause acceleration. Okay, so at first, what causes the object to turn is a force, and because this force acted on this object, so it's changed its direction. We then have change in velocity. Then we have an acceleration because of the existence of some kind of force that changed its direction. So forces actually cause acceleration. Okay, so let's talk about forces now. How can forces affect an object? From previous examples, we can see that it can change the object's speed and it can change the direction of the motion of the object. Okay, and we asked you to think about other ways of how force can affect an object. Okay, I will let you try it. For now, think about it. It's simple. Okay, now let's watch a couple of videos about forces to understand exactly what do we mean by forces, by the term force. We start by this video. Let's watch it.
Force. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate.
Okay, now again, we can notice that the ball was stationary and some kind of force has been acting on it, so it starts to move. Okay, so there is an acceleration here because the speed of the ball has been changed. Okay, and what is the reason for this acceleration is that some kind of forces acted on this body cause it to accelerate. Okay, let's continue.
When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean? Let's go back to our first example of this video. Here, in order to pass the ball to his teammate, the player must move it. That is, he must interact with the ball to move it in the direction of his teammate. He interacts with the ball by kicking it. The ball and the player interact with each other. In the second example, in order to move the desk from point A to point B, he must interact with the desk. We will study more on these interactions in the future videos. Now, since we are clear with the basic understanding of what force is, let me put its definition in front of you. It states that a force is a push or pull upon an object resulting from the object's interaction with another object. In the next lesson, we will talk more about these interactions. See you.
Okay, what about these interactions between the objects? That will be, as we will see, there are two kinds of forces. Let's watch this one.
At the end of the last video, I talked about interaction between any two bodies. Whenever two bodies interact, each one of them applies force onto the other. But how do the bodies interact? Interaction between the bodies can be basically of two types. One in which the bodies are in contact with each other, and the other in which they are not in contact with each other. The forces that result when the bodies are in contact with each other are called contact forces, and the forces that result between the bodies when the bodies are not in contact are called as non-contact forces.
Now, this is so important to distinguish between contact forces and non-contact forces. And now we will just learn about contact forces. Okay? And who can give me examples of non-contact forces will be considered as bonus mark for him or for her. Okay?
It's easy to think of contact forces, but it's a little difficult to think of non-contact forces, right? Yes, there are some forces which operate between objects even though the objects are not in contact. We will study more about non-contact forces in the future videos. First, we will discuss contact forces. Suppose that you're thirsty and there is a glass full of water lying on the table. In order to drink some water from this glass, you have to lift the glass towards your mouth. That is, you have to apply force on the glass. How are you applying this force? You are touching the glass with your hand and lifting it. Here, your hand is in contact with the glass. So the force you're applying on the glass is a contact force. Here is an example from the previous video. This player wants to pass this football towards his teammate, who is standing on the other side of the pitch. The player will apply the force on the ball by kicking it. When the player applies force, his foot is in contact with the football. So this force is a contact force. Other examples of contact forces can be pushing or pulling the desk from one point to another point. Here our hands are in contact with the desk. Similarly, pressing the keys on the keyboard, moving a piece on chessboard are some of the other examples in which parts of our body are in contact with the objects and apply force on them. In all the examples that we've seen till now, it is the parts of the human body that are in contact with the objects.
Okay, so these are contact forces. Okay, that's enough. Okay, that's enough for this video. Next video, we will see. In the next video, I will show you how to use the online simulation. Okay, so you can solve the homework that we have took on page 41 and 42, and how to use them to claim or to introduce the Newton's second equation, this equation here, Newton's second law, or the acceleration equation. We know now that force can cause acceleration, and this equation here, called the acceleration equation or Newton's second law of motion, this can be understood deeply by using the online simulation, which I will talk about in another video. Thank you very much.